All right, guys, one last thing. We talked about solving absolute value functions way back in Unit 1, so way back in August and September. We will be talking about how to graph these functions, which is super similar to quadratics. So we wanted to remind you guys how to solve them before we get to Friday. We know something is absolute value if it has these two bars. Don't confuse those bars on the EOC for ones. If you see those, remember that just means it always comes out positive, which is super similar to our squaring of a quadratic. So we know like x minus 2 squared equals 4. Whenever you square something, it also always comes out positive. That's why when we took the square root of both sides, we got plus or minus a number here, because 2 times 2 was 4 and negative 2 times negative 2 was 4. So the same thing is true here. Whether we substitute an 8 in here, it is true, or a negative 8 is also going to be a positive 8. So remember, these split into two equations, one positive and one negative, because if you take the absolute value of positive 8, it's 8, or if you take the absolute value of negative 8, it's 8. It's also a number's distance from 0, so you were saying your distance could be positive to the right 8 or to the left 8. So that's the other thing there. So then we just finished solving these. So we get our two solutions, much like we got our two solutions for our quadratics as well. So it's important that you see these similarities right now, because you're also going to see these similarities when we are graphing on Friday. All right. Same with the quadratics. You have to isolate like the squared piece in quadratics. You have to isolate the absolute value piece as well. So I get negative 3, absolute value of x minus 1 equals negative 15. Divide by negative 3. So I get the absolute value of x minus 1 equals 5. So remember, this splits into two equations. It could have been a positive 5 inside those absolute value signs, or a negative 5. So we get x equals 6 and x equals negative 4. And then finally, much like when we get this equals a negative number and you go to put it in your calculator, it tells you it's a math error or syntax error, because you can't do two positives to get a negative or two negatives to get a negative. So we had no real roots. Well, we don't talk about imaginary roots with absolute value, but we know that it's always going to come out positive. So could this ever come out as a negative 7? The answer is no. So since that's the case, since absolute value is always positive, that is not a solution, because the absolute value can't come out as a negative. All right, get going on your homework.